Good morning, everyone. We're going to start off with our homework quiz based on yesterday's lesson, which was on measures of spread, including range and quartiles and standard deviation. So this one's actually not much of a computational one, so more of a descriptive one. So let's say there are two waiters, A and B, and they keep track of the tips they make each day for a month. And when they compare the results at the end of the month, they find they have the same mean amount of tips per day, but A has a higher standard deviation than B. What does that say about A's tips? So just write me a sentence or two about what that means in terms of the tips that are made. So hopefully everyone's finished now, and if not, maybe pause the video if you haven't already, and we'll go on to the actual lesson. Again, today's lesson is actually going to be fairly descriptive as well. We're going to start focusing now a bit more on the normal distribution, some of its properties, because this is a very common thing that comes up in statistics. So as you know, the normal distribution has kind of that bell-shaped curve, so it looks something like this. Okay. So we're just going to list out some properties. So the first one is it's symmetric about the mean. So that means if you have a normal distribution, again, when you have a bunch of bars, it wouldn't look perfectly smooth, but sort of ideally, it would look something like this. Then the mean is going to be right at the center. Okay, and the symmetry, it has line symmetry about there. Okay, so that's where my mean is going to be. Okay. Second property is, and we mentioned this yesterday with standard deviation, right? How with one standard deviation, most of the data is within one deviation. Okay, so specifically, okay, with normal distribution, should be around 68%. So if I go one deviation each way, all right, and remember our symbol for standard deviation is sigma. Okay, if I go one deviation each way, then I have encompassed 68% of the results. Okay, and it's been measured out for more. So for two deviations, it goes up to 95%. So if I go the same distance again, so another standard deviation this way, and another standard deviation that way. Okay, so I've gone 2 sigma in each direction. That encompasses 95%. So, again, from yesterday, if we're talking about those bowling scores, right, 2 deviations would cover 95% of Kenny or Spenny's scores. Okay, and for Kenny, again, they only had 6 each, but yeah, I'm pretty sure all of his scores were in 2 deviations of the mean. Okay, if we took ourselves all the way to 3 deviations, okay, and on my little rough sketch there, it's kind of past the end of my curve, okay, but it becomes practically 100%. So 99.7% of the data is within 3 deviations. So if you have a normal distribution, right, if your data is spread out that way, okay, then when you calculate mean and standard deviation, pretty much everything has to be within 3 standard deviations of the mean. Okay, these last two ones, okay, are probably more for if you're gonna maybe study calculus, some of that stuff. This will make a little more sense. Okay, the point of inflection of the curve, so where it switches here from going like this to going like this, okay, concave down to concave up, okay, that occurs at that first standard deviation. Okay, that's where the curve flips. Okay, and if we're treating these like percentages, okay, so the bar graph was actually representing the percent of the data that falls into kind of each bin, the total area of the curve is going to be 1. And again, just for fun, this is the equation, okay, that will make the graph of this curve. Okay, so right again, there's our standard deviation, sigma occurring in there, and our mean. Okay, so if you know your mean and standard deviation and you have this formula, you can use it to make a nice picture of the bell curve on a program like, say, Desmos. And then there's that nice normal curve right there. Okay, so we're going to do a little more about notation here. Okay, so, and I apologize for the spacing here. If x is if a set of data x has a normal distribution with a mean of x bar and a standard deviation of sigma, okay, then we can write this. So my data x, okay, this little curve means it's normal with this mean and this standard deviation. Okay, and standard deviation squared is what's known as variance. Again, I'm not sure why the notation is set up that way, but that's the way that it is. So for example, again, if you're reading this or you see it in some literature in your textbook, okay, something like this, x is n 10 2 squared. That means you have a normally distributed set of data with a mean of 10 and a standard deviation of 2. Okay, and if I wrote it like this, x is normal 123.25. That means again that it's normally distributed, but because I didn't write the squared there, I have to think for a minute and say, okay, I take the square root, so my standard deviation is 5. Okay. So this is just a notation that's used, so just know what the notation means and how to write it down. And for our last example here, okay, sort of a practical application of how this works. Let's say an engineer wants to build an airplane seat that can comfortably accommodate 95% of the population. Okay, and the average adult mass is at 71.8 kilograms plus or minus 13.6 kilograms. What range of masses should she anticipate? Okay, so what size of people will they have 95% of the time? Okay. So again, we talked about this the other day with distributions. Something like mass is going to be normally distributed over a large sample. Okay, so to think about what's going on here, again, I'm going to do a rough sketch of the bell curve. Okay, and in here, what this is noting, right, this would be my mean. Okay, so I'm saying that the average mass is going to be 71.8. Okay, and 13.6 then, this is going to be my standard deviation, right? That plus minus is indicating my standard deviation. So, in terms of the graph here, okay, says we want to accommodate 95% of the population. So from that list of properties we had, right, 95% of the population is 2 standard deviations away from the mean. And I'm just going to roughly sketch out one. So there's 1 deviation. And there's 2 deviations. Okay, and I have to go in both directions. So 1 deviation this way, 2 deviations this way. Okay, so in terms of what range of masses, well, I just need to find out where these points are. So each deviation is 13.6. So for instance, to go to this point here, I'm just going to start with my 71.8, right, and add 13.6 twice, okay, which I believe that takes me up to 99 kilograms. Okay, and going the other direction, okay, I'm going down twice, so I would have 71.8 minus 13.6 twice. And I'm going to grab my calculator for a sec because it's not coming to me. So 71. Okay, 44.6. Okay, so therefore, the range of masses is 44.6 to 99. Okay, so that's what they should anticipate in terms of what the seat should be able to handle. Okay, and I guess as a final disclaimer here, I have no idea if it is actually the average adult human mass. I just made that stuff up. So that's pretty much it. Okay, now this right here, this kind of setup, drawing the diagram, laying out the standard deviations, thinking about what it means. Okay, that's a pretty important skill here. Okay, and quite a few of the questions in the homework are going to ask about that. Okay, so there's all some thinking, setting up, and looking at what it means. Okay. So what I'd like you to do now, okay, on page 175, there's an example there I'd like you to read. Again, it shows a bit more of what we just did here, some graphs and how to interpret what standard deviation means and how much of the distribution you're talking about, what percent. And here's the practice work that I would like you to have a look at. Okay. So get to work on that and have a wonderful morning, and I will see you on Monday.